All right, guys, so I'm going to go over the last two of these to show you how you would complete these problems, and then I'll show a few of the actual inequality shading so you guys know how to complete these. So these are the problems that you are going to have a single variable and you need to solve using that single variable. You're not going to solve algebraically. That is not the whole point of this process. So if I were to do the first one, I would distribute the 2/3. So if I distribute the 2/3, this becomes 4/3 x. And the x is in the numerator, but this is just the way I'm writing it. And then -6 times 2 is -12, divided by 3 is -4, and then -8. So usually we would add the 4 over, multiply by 3/4, and so on and so forth. But we want to be able to graph it. So to graph it, we're going to add 8 to both sides. When we add 8 to both sides, we have 4/3 x plus 4 is less than 0. So we're going to act like this is y. So if this is y, we have y equals 4/3 x plus 4, and we're going to graph that. So you start at +4, so 1, 2, 3, 4. And then I go up 1, 2, 3, 4 over 1, 2, 3. Down 1, 2, 3, 4 over 1, 2, 3. Down 1, 2, 3, 4 over 1, 2, 3. And down 1, 2, 3, 4 over 1, 2, 3. And then we draw our line to connect it. Should be a straight line, but it's hard to do it on here. So then we're going to substitute y back in. So we're going to see where y is less than 0. So if we take a look, we know y is 0 at -3. So if y is 0 at -3, we want to find where y is less than 0. Y is less than 0 at all these points down here. So we see when y is less than 0 that our x values are over here, and that means our x is less than -3. So that would be our answer. X is less than -3. And that helps to show us that all our values down here are y less than 0 and our x is less than -3. We can't say less than or equal to because we want when y is less than 0. Y is 0 at -3, so we can't count that in. All right, the next problem. We want to get everything onto the left side because we want to have the 0 on the right. So I will subtract 2x and add 9. So subtract 2x and add 9. We get 5x plus 5 is greater than 0. So we have to be careful which way our inequality symbol is facing, and that will be shown in a couple minutes. So we start with 5. So 1, 2, 3, 4, 5. Then we go up 5. 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5 over 1. And we connect it. I don't know why that's not working. There we go. And of course it's supposed to hit all points, but it wasn't working, so it's a little funky. All right, so now we look. We box it off. And we want now y is greater than 0. So we know y is 0 at a -1. We want to see where y is greater than 0. So y is greater than 0 at all these points up here. So up here is when all our x values are this way. So that's when our x is greater than -1. And that would be our final answer. Now we're going to use our x and y axis. So our first step every time is act like this is an equal sign. So we're going to graph 4x minus 3. And then we're going to go up 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, and then down 1, 2, 3, 4 over 1. And then we connect it. And because it is a greater than sign, we're going to have some dashed lines. I hate when that happens. And put the arrow so you know it's continuing. All right, so now we have to test points to see where we should be shading. So we're going to test a point on this side of the line. I like to pick 0, 0. and then on this side of the line. And I like to have a 0 in it, like I said in class. So if we have 0, 0, we're going to plug it into here. So y is 0, x is 0. So 0 is greater than -3. All right, that works. But what if I did my math wrong? Let's check the other side just in case. So this would be 1, 2, 3, 4. This would be 4, 0. So 0 is greater than 4 times 4 minus 3. Plug the point in. 4 times 4 is 16, minus 3 is 13. 0 is not greater than 13, so this side works. And if you wanted to double check just in case, you could plug in another point over here on this side as well, and it will work and make sense. All right, let's try one like this. So for this problem, we have to get the y alone. So when we use the literal equations, we had to get y by itself. So to get y by myself, I subtract x from both sides, and I get 2y is less than or equal to -x. I divide by 2, and this is what I get. So then you have to pick points after you graph. So I'm going to start at 0, 0, because this is the same thing as saying plus 0, so it tells me start at 0. It's negative, so I go up and 2 to the left, up and 2 to the left, up and 2, and then down. And we connect it. So we're going to connect this with a solid line because it's or equal to. So these points are included. So we're going to pick points. I picked 0, -1. And I picked 1, 0, because those are on each side. I could have picked one all the way over here or all the way over here. This was just my preference. So then I plug it into this equation. So 0 is my x, -1 is my y. -1 is less than or equal to 0. That works, but let's just test the other one just in case. 0 is my y. So is 0 less than or equal to -1/2? No. So my 0, -1 works, so I'm going to shade below. So we have to be used to changing our equation to get it into the y equals mx plus b formula so we can graph it properly. So you will see some questions on that on future assessments. So if you guys have any further questions, please don't hesitate to email me, all right?